Hello friends, welcome to aimstoday YouTube channel. Here we are going to discuss about IIT-JEE NEET Foundation Chemistry in that atomic structure part 5. In this we discuss about electromagnetic radiations. What are these electromagnetic radiations? This is a form of energy that is produced by the moment or oscillation of electrically charged particles which are traveling through either vacuum or matter. Here you can see different kinds of electromagnetic radiations are shown. Actually, these electromagnetic radiations do not need any medium for their propagation. That means they can travel even through vacuum also. Visible light, ultraviolet radiation, infrared radiation, X-ray, gamma ray are examples for these electromagnetic radiations. Characteristics of these electromagnetic radiations. Electromagnetic radiation is released as photons. As we discussed in the Planck's theory, this energy will be released in the form of photon, which are bundles of light energy that travel at the speed of light. Electromagnetic radiation can travel through even empty space, that means even through vacuum also. Most other types of waves must travel through certain medium. That means, for example, sound waves need certain medium for their propagation, like solids, gases or liquids, through which it can pass. An electromagnetic radiation is always characterized by certain properties. Now let us see these properties here. Among them, the one is wavelength. The distance between the two nearest crests or troughs is called as a wavelength of that radiation. It is denoted with the symbol lambda, and it is measured in terms of centimeters, angstroms, etc. Here you can see a picture of wave is given. Here this is called crest and where it is called a trough. The distance between the two nearest crests or nearest troughs is considered as a wavelength of that radiation. It is denoted with the symbol lambda. As it is a distance, its units will be generally centimeters, angstroms and so on. Most frequently used units are angstroms. As we know, 1 angstrom is equal to 10 to the power of minus 8 centimeters or 10 to the power of minus 10 meters. Here you can see some other unit conversions also for this length. Next one, frequency. It is defined as the number of waves which pass through a point in unit second, 1 second. It is denoted with the symbol nu, and it is measured in terms of cycles per second or hertz. Here frequency is inversely proportional to wavelength, that we can mathematically represent it. Nu is inversely proportional to lambda. To remove the proportionality, here a constant c is taken, which is equal to the velocity of light. Thus, a wave of higher frequency has a shorter wavelength, while a wave of lower frequency has a longer wavelength. As we told, frequency is inversely proportional to wavelength. Longer wavelength waves such as radio waves carry low energy. That is why we can listen to the radio without any harm consequences. Whereas shorter wavelength waves such as X-rays carry higher energy that can be hazardous to our health. That is why aprons are worn to protect our body from harmful radiations when we undergo X-rays. Frequency and wavelengths of different electromagnetic radiations are shown here. We can observe. So radio waves which are having longer wavelength, so they are having lowest frequency, whereas X-rays and gamma rays you can observe here, they have very low wavelength which are having higher frequency. Next, character wave number. This is the reciprocal of wavelength. To say simply, the number of wavelengths per centimeter. It is denoted with the symbol nu bar. It is expressed in centimeter inverse or meter inverse, as it is a reciprocal of length. We can show mathematically nu bar is equal to 1 by lambda. That means it is reciprocal of wavelength. Next step, property amplitude. It is defined as the height of a crest or depth of a trough. It is denoted with the symbol A. determines the intensity of radiation. So a height of a crest or depth of a trough is considered as the amplitude. Next property, velocity of electromagnetic radiations. It is defined as the distance covered in 1 second by the wave. It is denoted by the symbol c. All the electromagnetic radiations travel with the same velocity, that is 3 into 10 to the power of 10 centimeters per second is the velocity of all the electromagnetic radiations. The distance traveled in 1 second is equal to 3 into 10 to the power of centimeters, 10 to the power of 10 centimeters. Next property, time period. Time taken by the wave for one complete cycle or vibration or oscillation is called as time period of that wave. It is denoted with the symbol t. Its units are second per cycle, that means time taken. The arrangement of various types of electromagnetic radiations in the order of their increasing or decreasing wavelengths or frequencies is known as electromagnetic spectrum. Here you can see electromagnetic spectrum, which is shown with the different types of electromagnetic radiations. Here at the starting, radio waves are there which are having longer wavelength or higher frequency, lower frequency, and here X-rays and gamma rays are there with a lower wavelength with a higher frequency. This we can say electromagnetic spectrum. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.